Alright, hello. This is another lovely math lesson from your friend Mr. Bryant. Here to talk about combining like terms. So, combining like terms, what are we talking about there? Well, keyword is like and combining and terms. So I guess they're all pretty key terms here. But the deal here is like. We want them to be like terms. So, let's look at this first example. 2a plus 3a. Do you think we can combine those like terms? Notice my eyebrows said like terms. Well, let's look. They are like terms because they both have A's. What you want to think about is, let's say that this is an apple. Well, you have 2 apples and you have 3 apples. So 2 apples plus 3 apples, don't take a rocket science to figure that out. There's 5 apples. I knew you had it in you. So, let's look over here. 4b minus 2c. 4b minus 2c. You think you can put that together? Are they like terms or are they not? Well, the only question you could ask yourself is, can I put 4 boys and minus 2 cats? Can you take 2 cats from 4 boys? Well, in reality you can, but if they're the same, then you could. But here, you only could take 2 cats from 4 cats, but that's not cats, that's boys. So, I can't do anything with this. So this is as far as this problem can be simplified. You can't go any further because I didn't realize my head was in the way. 4b minus 2c is done because you can't put boys and cats together. You can't subtract them, you can't add them because they're different things in life. Alright? Now down here I got a doozy for you just to throw you into the ball game. We have 6c plus 4b minus 4c minus 2b plus 5d. So what we want to look at is, try underlining. That always helps me. And hey, if my teacher told me that's what always helps me, I think I would follow their lead. So, 6c. That's going to go with 4c. Notice it's a minus 4c, so be careful. So 6c minus 4c, I'm going to hop over. 6c minus 4c is 2c. Now I'm going to underline, well, let's do a different thing. A little circle underneath both the b's. 4b minus 2b, because of that minus sign, 4b minus 2b is a positive 2b. Okay, always write the sign of what happens after you've done your math. And then last but not least, we have a plus 5d. Well, there's no other d's in this whole expression. So I'm just going to bring it on down. That's right, I said it. Bring it on down. So now this is our simplified expression. Alright? And again, at any time during this recording, you can always pause the tape and write it down. Okay? So now let's look at just a few more examples before we wrap this up. Now, we have 5a plus 7b minus a minus 2b. Now notice one thing about this that's different. All of these have numbers except for this one. Well, how many a's do you see in this spot? I'm not talking about those 5 a's, those 5 apples over there, just this apple. There's 1 apple. So you can always put a 1 to the left of the variable because there's one of those shown in that position. So now we're ready to do our work. Well, 5a matches up with 1a. So 5a minus 1a gives you 4a. Then I'm going to do a little circle to be different. 7b minus 2b is a positive 5b. Okay, can I put 4 apples plus 5 bongos? No, bongos and apples don't go together. So that's why this is your simplified version. This is your simplest form. This is your solution to this expression as we have simplified it. So now we have 2x squared minus 3x plus 12 plus 4x minus 5x cubed. Well, now you're saying, Mr. Bryant, and thrown in there some exponents. You're trying to fool me, but I can't fool you because you know what you're doing by now. Because you've paused the tape, you've written it down, and you're taking it into your brain and computing all this knowledge. So, why did I throw it out at you? Well, we know that a squared is not the same as a cubed, or it's not the same as an x with no exponent. So, this like term, does it have any friends to go with? No, it doesn't. So we're going to bring it on down. But this x matches up with this x because there's no exponents. So negative 3x plus 4x is a positive 1x. This 12, can that go with somebody? No, so we're going to bring it on down because there's no other numbers that don't have a variable. If I had a plus 1 over here with no variable, then this 12 will go with that 1. But we don't have that during this problem, so we're just going to bring it on down. Now, we've already dealt with that and that, so let's skip over it. Now this minus 5 cubed, it has nobody to go with. So we're going to bring it on down with the minus 5. Now notice that we have a square, we have an x, and we have a cube, and we have a 12. What we want to do here is, it's just a habit to write these in the order of biggest exponent to no variable at all. So the first one we start would be the minus 5x cubed, or the negative 5x cubed. Then the 2x squared will come next, then the 1x will come next, and then the plus 12. Because if we add a little 1 here, you're allowed to do that because there's an imaginary 1 there, because it's just an x, so it has 1x to the first power. So we have a cube, a squared, a 1, and no variable at all. So this is our simplest form. Okay? And just to throw one more example out there, notice that if you had a 3x cubed plus a 1x squared minus a 2x cubed, which ones would go together? Well, the cubed and the cubed will go together for these 3's, and you don't do anything with the variable in the exponent spot. You only do something with the number in front, the coefficient that's touching the variable. So this 3 minus this 2 will give us a 1x cubed. Notice that I did not change the exponent. It's still a cubed. Okay? And then we're going to bring down, or bring it all down, the plus 1x squared. Okay? This is our simplest form expression because we don't have anything that's alike. The cubed and the squared are different. I know you see those x's there and you think they're the same, but they're not, because x cubed and x squared are different types of variables with a different exponent. Let me rephrase that. The x's are the same, but the variable makes them different. So they're not the same kind of terms. They'd be exactly the same term. X cubed matches with x cubed, x squared with x squared, x to the fifth, x to the fifth. Those type of terms we can add together or subtract together, but not these. So that concludes this lesson on combining like terms. Hope you enjoyed.